Okay, ladies, we are taking notes on worksheet 4-6, and here we go. Is everybody ready? Okay. Our topic today is negative exponents. All right, that's our topic, negative exponents. And there's a couple of little, well, there's one little precursor to it. We did this sort of already, but let's just make sure we have it really solid. If you have x cubed over x cubed, then what's specific about that is that they're the same, okay? The long way, when you expand it, this is the way we don't want to have to do every time, but it does work, is expansion. And everything cancels. And when everything cancels, and it's all gone, you're not left with 0. What are you left with? 1. Okay? So everyone agrees that x cubed divided by x cubed is equal to 1. It's not equal to x, it's just equal to plain old 1. Okay? Well, we also learned a different rule. We learned that if you have division here, what can you do to those two exponents? You can subtract them. And we usually subtracted them in our head, and we looked at these two exponents right here, and we said, what's 3 minus 3? 2. And that gives us x with a power of 0. This is what our second rule tells us, okay? Well, if one rule tells us the answer is 1, and the other rule tells us the answer is x to the 0, then that must mean that x to the 0 is the same thing as 1, okay? This doesn't show up all that often. It's just one of those little details that shows up every once in a while, and when it does, I need you to make sure you get it right. X to the 0 is not x. X to the 0 is not 0. X to the 0 is 1. Okay? So here it is written, it's a key concept. Here it is written sort of in rule form. And the thing is, you just take a look at the base. There's one little exception to this. 0 to the 0 doesn't mean anything, but we're not going to worry about that, okay? You have any base except for 0. If your base is a 0 power, the answer is 1. So let's just put a handful of examples down here. And I say, what's 5 to the 0? You will say 1. If I say, what's 2 to the 0? 1. The answer will be, well, see why I'll say 2. Anything to the 0 power is 1. So what's 2 to the 0 power? It is 1. I know that feels weird, doesn't it? To say that 2 to the 0 is 1. But any base raised to the 0 power is 1. Okay, no matter what it is, whether it's a variable or a number. So if I say negative 3 to the 0 power, everyone, the answer is 1. Okay? Sometimes the problem is a little, I don't know, bigger, messier. It looks bigger and messier. What are all three of these things? What power are all of these things raised to? The 0. Therefore, what are all of those things going to turn into? 1. They're not going to turn into 0, they're going to turn into 1. Okay? So it actually turns out to not be hard. You do have to pay attention to which things are raised to the 0 power, which bases. In this next example, which of the bases are raised to the 0 power? All of them or just some of them? Just some. Just the x and the y. So that 0 power right there doesn't affect the 9. So this stays the same because it doesn't have the 0 power on it. X to the 0 becomes 1. Y to the 0 becomes 1. And this whole entire answer turns out to be 9. So it's just the part that has the 0 exponent in it. Okay. So let's have room for 2 more examples on the page here. We're not going to get all freaked out by little fractions. As long as everything in the fraction is understandable, we should still be able to apply the rules to it. What all does this 0 attach itself to? What all is it applying itself to? The x and the 2. So what are both of those things going to become? 1 over 1, which is plain old 1. And compare that to this one, which doesn't have parentheses. And what's the only thing that zero, I put that way high, let's put that a bit lower. What's the only thing that zero is attached to? Just to the x. So when you change something to a 1, this one changes to a 1, but this stays a 2. That make sense, everybody? This zero power doesn't show up a lot, but when it shows up, it tends to cause a little confusion. So just remember to go back and look at these notes as that comes along. Okay? All right, now let's actually get to the negative exponent part. Okay. All right. So just a bit of review, if we wanted to work this problem by expanding, there would be 3 x's on the numerator and 5 x's in the denominator. And they would, 3 of them would cancel out. We'd end up with a 1 in the numerator and an x squared in the denominator. That's old stuff, yes? And what we decided is that we could just look at it and subtract and put it in the right place. That is still an excellent skill, and we're going to want to use it a lot. Subtract it and put it in the correct place. But there is a rule that says we can also just subtract them. Okay, so if I just subtract these two exponents, what does 3 minus 5 actually equal instead of 5 minus 3? What does 3 minus 5 actually equal? It actually equals negative 2. So this is our first taste of a negative exponent. Okay, this is a thing that carries forward into, especially when you get back to your pre-calc class, you will spend a lot more time on these. Okay, so what I'm going to look at is noticing that I have worked a problem 2 ways, and I've gotten 2 different answers again. And if I didn't make a mistake, then that means that the 2 answers must be the same thing. They must be the same thing, and in fact they are. Okay? So we're going to have to take this idea of a negative exponent and figure out how to fit that rule in with everything else that we've done. The basic rule is that you're going to take a negative exponent and you're going to write a reciprocal. That's what a negative exponent means. You're going to write a reciprocal. And when you write a reciprocal, you're going to change the exponent to a positive. You have to do 2 things, reciprocal and change the exponent to a positive. I'm going to pause for just a second and have you get your calculators out. Okay, pull their calculator out. We're not even going to write these down, but I want you to pull down and type a couple of things in for me. Very, very, very smart people taught your calculator this rule. They didn't make a calculator and suddenly the calculator taught them a rule. That's not what happened. They taught the rules of the calculator and it knows this rule. So I want you to see what happens with some numbers that have negative exponents. We're primarily going to do variables, but the numbers also work. But everybody type in, please, the fraction 3/4, and please put it in parentheses like this. Type it in parentheses 3 divided by 4. Type it in like that. Type that in. Everybody got typed in? You don't need to write this down, I promise. Okay? So then I want you to do the exponent key. Do you remember what that looks like? It's this little hat key. Y'all remember that? Yes? Okay, now before you hit enter, can y'all tell me what is the reciprocal of 3 over 4? What's the reciprocal? 2 over 3. Now I want you to hit enter. And I want you to do math 1. And what does it say? 4 over 3. So that little negative exponent means do the reciprocal. Does everybody see what I'm talking about? We are working with this primarily with variables. It also works with numbers, and you'll do that a little bit more in Algebra 2. We're going to do it primarily with variables. Do another one for me, and before you type it in, tell me what you already know. What's the reciprocal of 2? Stop. What's the reciprocal of 2? 1/2. Okay. So type in 2. And then put a negative 1 as an exponent. You don't need to write these down. This is just for a little side note. That's what I said. You don't need to write this when you cut your buttons. Okay? And what does your calculator tell you when you say 2 and you put a negative 1 power on it? 0.5, which is the same thing as 1/2. So, like I said, we're primarily going to be working with variables with negative exponents, but I wanted you to see that it also works with numbers. This is our key word here. When you see a negative exponent, your brain has got to think reciprocal, okay? All right, so let's get a couple of examples. I think I have 6 or 8. When you see x to the negative 1, you need to flip it over. Calculators away, they're not going to help us anymore. We got it wrong, but they're not going to help us. When you see x to the negative 1, you need to do the reciprocal. So right now, x to the negative 1 is in the numerator, and you need to flip it over and put it in the denominator. That's the reciprocal. Like the reciprocal of 2 is 1 over 2. The reciprocal of x is 1 over x. Does everybody see? Yes? Okay. Second one. If it says x to the negative 3 instead of negative 1, you also need to do the reciprocal. So this is over 1. That's where it is. It's in the numerator. So you need to flip it and put it in the denominator. And when you put it in the denominator, the power is not going to be negative 3 anymore. It's going to be positive 3. Okay. So what if I give you an expression where the negative exponent starts in the denominator? Well, when you do a reciprocal, what happens to the thing that's in the denominator? Where does it go when you do the reciprocal? It goes to the numerator. Okay? So we're going to flip this up to the top and put it in the numerator, and when we do that, the exponent's going to become positive. Everybody see? Okay. And then you usually take that 1 off of there. Just to do a one number one, we're not going to do a lot with numbers, mostly variables. But if I get this number, look at the exponent. What is the exponent on the 2? Negative. What are you supposed to think when you see a negative exponent? What word? Everybody say it. What are you supposed to think? Reciprocal. And reciprocal means from the top goes to the bottom, and the bottom goes to the top. So you flip it, yes? So instead of putting the 2 in the bottom, you're going to move the 2 to the top, and 1 over 2 to the negative 1 is just plain old 2. And 2 more examples. You do one with a number. And then I'm going to do one that's got just variables. Okay, these are fractions. Okay? So when you do a reciprocal, this negative right here, this negative tells you to do the reciprocal. What's the reciprocal of 1 over 5? 5 over 1. I'm going to flip this. Well, we can flip it. 5 over 1. And then what's the other thing? Flip it and do what else?
Make it positive.
Make what positive? The exponent. Make the exponent positive. So the exponent, instead of being negative 2, will be positive 2, and then we know what that is. 5 squared is 25. Okay? All right? So back just to the variable part. Copy this problem, only make that exponent negative. X over y to the negative 2. So what does the negative, everybody say this out loud, what does the negative exponent tell you? Reciprocal. So you do the reciprocal, this will become y over x. And at the same time, when you do the reciprocal, what happens to the exponent? It becomes positive. Does everybody get the idea? Yes? Okay. When you first learned this symbol right here, does anybody know what that symbol is? What is it? How many of you remember being a little confused about it at the beginning and it causing you a little bit of trouble sometimes? Yes? And every once in a while it still causes us trouble. But if you practice it enough, then you will get more comfortable with it. Okay. So, what if we have multiple bases? What if there's x's and y's and they're not all raised to the same power? Okay? So, the idea here is that you can only do the reciprocal for the base that has a negative exponent. All right, we'll write that down in a second. So look at this first example. Which base has a negative exponent? Just the x. So we're going to leave this one in the top, and we're going to move this one to the bottom. So you only do the reciprocal if the exponent on that base is negative. Does that make sense? Only for that one part. Okay? So look at the second example. There's an x and a y. Which one of them has a negative exponent? The y. So what are we going to do with the x? Leave it at the top, and we're going to take the y, and we're going to put it on the bottom. So here's our little note right here. If the base in the numerator has a negative exponent, if the base has a negative exponent, move it to the denominator. Denominator, there it is. And make the exponent ran out of room, positive. So if it's in the numerator and it has a negative exponent, then you just move that part. Leave the other part where it was. Okay? Those. All right, look at the next two examples. This time, where do both of my bases start? Are they starting in the numerator or the denominator? Where are they starting? Where are these two bases starting? The denominator, they're in the bottom, okay? So when you do reciprocals, if something was in the bottom, when you do the reciprocal, it ends up in the top. So which part of this are we going to switch up and move to the top? Y to the negative third is going to switch up to the top, and that's right. When it goes to the top, it's going to become y to the positive third. Now, why do we not move the x squared? Why does it stay in the bottom? If it's a positive, you don't move it. You leave it where it is. Okay? All right, so look at the next one. What part's going to move this time? The x. It was in the bottom, so it's going to move to the top, and the y is going to stay on the bottom. Follow? All right. If a base in the denominator has a negative exponent, what do we do with it? And don't forget, make the exponent positive. Pretty much everything about this with negative exponents is about making sure you only move the pieces you're supposed to move, and that you leave the other pieces where they are, okay? And that's kind of what we're going to be doing as we work through the next ones from easier to more complex to the most complex problems today. All right, so here's 4 examples, and you can see they're all x's and y's, and they're all x squares and y's. Oh, I've got one with the 4. Some the negatives are in different places, and they start in different places. And your job is to figure out which piece is going to end up where, okay? So, where is the x? Numerator, let's just say top and bottom. Top or bottom? Top and bottom. Exponent is positive or negative? Negative. So where is it going to end up? Top. In the top. Okay? Where's the y? Where does it start? Bottom. Is the exponent positive or negative? Negative, so where's it going to end up? In the top. If everything ends up in the top and the bottom has not got a 0, the bottom has a 1. And when the bottom has a 1, we usually just leave it off. Whoops, that's very wacky. Okay? Now, did we move both the x and the y? Yes. Why? Well, both of them had negative exponents. Look at the next example. Are we going to move both of these? No. What's the other one we're going to move? The y. We're going to move the y. So the x stays where it is, we move the y up to the top, and once again, nothing else is on the bottom, so that's all, our answer is x squared y is 4. There's nothing on the bottom, there's 1 on the bottom. Okay? Next example. Which one do I move, the X or the Y or both? Both? Okay, what makes you move it? What's the reason for moving it? What's that? Move me. What says that? Negative what? Negative exponent. So, do I move the X? Yes. Do I move the Y? No. All right, so the X goes to the bottom, and the Y stays on the bottom, and there's nothing in the top. What do you have to put up there when there's nothing there? A 1. Okay? So what does the negative exponent tell us to do? Move it. Positive exponent, don't move it. All right, take a look at this next example. Do I move the X? Yes. Do I move the Y?
Yes.
Yes. And there's our answer. Okay? You move bases if they have negative exponents. Only move the bases if they have negative exponents. Right? There we go. So next we're going to throw in coefficients. So our biggest problem with exponents is starting to get mixed up between what we do to exponents and what we do to coefficients. And we've already worked on that a little bit, so we're just going to keep working on it here. The last thing I said was only move the base if it has a negative exponent. Yes? Okay, does this 2 have a negative exponent?
No.
No. So the 2 stays on top. Does the X have a negative exponent?
Yes.
Yes, so the X moves to the bottom. Does everybody see? The 2 does not have a negative exponent. All right, look at the next one, 1/2. Does the 1/2 have a negative exponent?
No.
No, don't move it then. I'm gonna put a 1 and a 2. When we flip this X over, you remember how I've told you before, if it's in the middle, that's the same thing as being on the top. Y'all remember that? So this is on the top right now, so where does it need to flip to? The bottom. It's gonna go down there and join that 2. That's the way we usually write it, as one big fraction. Okay? Does everybody see why the 1 and the 2 and the X all ended up where they ended up? All right, take a look at the next example. We'll put a fraction here, fraction bar. And your job is to put each of those pieces in the correct place, all right? The rule is, if it has a negative exponent, flip it. If it doesn't have a negative exponent, don't flip it. So everybody try this example. Okay? Does this number right here, -3, does that have a negative exponent? No, that's a negative coefficient. You don't flip negative coefficients. Okay? Does the X have a negative exponent? Yes. Where does it need to go? Down to the bottom. Does the Y have a negative exponent? No. So where does it stay? Right where it is. Okay? All right, I'm going to let y'all try the next, actually, just try the next 3 problems. Don't do the last 2 until we've checked to see if you've got the next 3. Everybody try the next 3 problems. I'm going to hit pause on the recording for just a second so I can find the pause button. Okay. Had time to do 3 problems, so here we go. I always just do these by starting with the fraction bar there. Okay. Do I move the -3, everybody? Do I move the -3?
No.
No, leave it on the top. Do I move the 4? No, leave it on the bottom. Do I move the X? Yes, goes to the bottom. Do I move the Y? Yes, goes to the bottom. Does everybody see how it works? Once you get a hang of it, it goes pretty quickly. Okay, next example, do you move the 4?
No.
No. Do you move the 3? No. Do you move the X? Yes. Do you move the Y? No. One of the most common mistakes is for people to say to themselves, if it has a positive exponent, put it on the top. That's not right. If it has a positive exponent, leave it where it is. Okay? Leave it where it is. Don't flip it. Okay? And the next one, we don't move the 4, we don't move the 3, we don't move the x, and the y comes up to the top. And no negative exponents in our answers. Yes?
Both variables are on the bottom, so I don't know.
No, it doesn't, but nice, alphabetical is kind of a nice word. Okay? Did y'all hear her question? Yes, you can put the y before the x. Okay, last two. Draw a bar, and see how quickly you can do those last two problems on these examples. Take a look up here and see if you have a plot. It's not really very hard, is it? It's just a new rule to kind of get used to and keep up with. So one thing I want you to write at the bottom of the page here is do not, if I say flip, y'all will know what that means. Negative coefficients. You only flip things if they have negative exponents. So note yourself, do not flip the negative coefficients. Is that a question, Jayla? What's that?
I like to add the one.
Okay.
Is that okay?
As an exponent? Okay, so you can add the 1 right here, and that's not wrong. Eventually, by the time you finish algebra 2, probably, you should sort of work out of that right down spot. Okay? It's the same thing as if you leave a 1x. It's not wrong, it's just not considered quite as simple as it could be. All right? Okay, now we have 8 more examples to do, ladies, and they are the more complex ones. They require us to do 2 things. So here's the steps I have written for you. First, go through and move everything that's supposed to be moved. Do the reciprocal of anything that has a negative base. And then you're going to have a problem that looks like what we've already done. Does that make sense to everyone? First, do the new rule. Then you're going to do the old rules. So what I'm going to do is I'm going to put, actually, I'm just going to put one big fraction bar here. And I'm going to move anything that needs to be moved. I like to go through and move these things based on, I like to do all the coefficients, and then I like to do all of the variables. So do I move the 2? Do I move the 2? No, keep it on the top. Do I move the 4, ladies? No, keep it on the top, so I'm going to put it right there. Do I move the x squared? No, keep it on the top. Do I move the x to the negative 4? Yes, I'm going to move it to the bottom. And I like to line them up so the x's end up underneath each other. It just makes it easier for me to see what I'm doing. All right? Do I move this y to the negative 3? Yes, it goes to the bottom. Make sure you change it to a positive, and I don't move the y squared. So what I end up with here is some stuff on the top and some stuff on the bottom, and now I just apply the rules that I already know. Okay? All right, first of all, bless you. What's 2 times 4? 8. Okay? Look right here. What do I do with that? X goes on the bottom. How many of them? X squared. And then look right here. Y goes on the bottom. How many of them? 1. Y'all see how that works? Well, what did I do? Okay, thank you. I'll give you on page 26. Okay. I'm going to tell you flat out, especially if y'all have a tutor, there are other ways you can do this that get you to the same answer. This is the way that I think is the least trouble. How many of you prefer negative numbers to positive numbers? Yeah, nobody does. So this method gets rid of the negatives first, and then we don't have to fool with it. Okay? All right, so let's try it on the next one. So we're going to put one big fraction bar. Boom. And we're going to land everything where it needs to go before we start multiplying, adding, subtracting, or anything. Okay? What do I do with that negative 3? Leave it on the top. Okay? I like to go through and do all the coefficients. This is the way I like to organize them. Then I do this one, and then I do that one. So it's that one on the top. Okay, what do I do with this x? Move it to the bottom. And what do I do with this x? X to the 4th. What do I do with it? Leave it on the top like that. And see, you see how I'm lining them up so my X's are above each other so I can see them a little bit better? Okay, what do I do with this Y? Bring it to the bottom. And what do I do with this Y? Leave it on the top. Okay? So, -3 times -2 is 6. Oh, shoot, you're right, 6. I wrote -6, that was wrong. It's 6. Okay, look at your X's. Where are they going to end up? On the top. How many of them? X squared. Look at your Y's. Where are they going to end up? On the bottom. How many of them? 2. So, want to see how that works? Okay. Giant fraction bar. See if y'all can put everything where it belongs. Correct. The 3 and the 4 on the fraction, the 3 goes on the top, the 4 goes on the bottom. Remember, try to do your coefficients and get them up to the front, okay? Get them forward. It usually makes life a little bit easier. Okay, this m to the -2 goes to the bottom. And I like to just scoot it over so I can see it better. And this m to the +3 goes to the top, stays on the top. This n to the 3 stays on the top. And this n to the -1 goes to the bottom and has a +1 on it. Yes. Yes.
What you could do.
Hang on just a second. Let's make sure everybody has everything in the right place. Does everybody have everything in the right place? Questions about that? Okay, now you do stuff you already know. So this you've actually been doing since, I don't know, 5th or 6th grade. You need to say 3 times -4, which is -12, and -12 divided by 4, which is, I think it's -3, right? So it's going to be a -3. And then you need to do your variables. How many m's are we going to have left over? 1. And where's it going to end up? On the top. And then you need to do your n's. How many n's are we going to have left over? And they are going to be on the top. And when everything is on the top, we usually just take off the denominator and write the answer this way. Okay? All right. Everybody give this one a try. Put everything where it belongs first. Move everything first. Where does it belong? And when you put everything where it belongs, look up and see if yours looks like mine. If it does, go on to the next step. If it does not, then raise your hand and let me help. Very good. Sage. Okay. All right, so what happens? What happens to the X's? They cancel out. What happens to the Y's? They cancel out, and this answer turns out to be -10. Just -10. Okay? All right, we're almost there. Okay, that's a long one. Negative exponents are super important for upper level, for the study of upper level math. And so I guess we'll just take a little bit of time on it. We're going to do the same thing. These are now division problems. We're going to do the reciprocals for all bases with negative exponents. That means move things to the right place. And then we're going to use our other rules. And the thing that happens right here, and this is what Shayla asked a few minutes ago, is be careful. You're supposed to reduce your coefficients, not subtract them. Okay? So I'm going to do the first one with you, and then I'm going to let y'all do the other 3 by yourselves. All right? So let's do the first one together, and then I'll let y'all do the other 3 by yourselves. Okay? Set up the big fraction bar. Remember, you only move things that have negative exponents. Okay? Do I move the 3? Do I move the 3? No. Do I move the 6? No. Do I move x cubed? No. Do I move x to the negative 4? Yes. And since it started on the bottom, where do I move it to? The top. Don't forget to change it to a positive 4. Y'all see what happened there? Yes? Okay, what about y to the negative 2? Do I move it? Yeah, so it goes down to the bottom. Make it a positive exponent. Do I move this y right here? Nope, leave it right where it is. Okay? Now, we haven't actually seen this before, but it is the rules that we already know. You have to just look at it and pay attention to the rules. We reduce the coefficient. 3/6 is 1/2. Okay? What do we do to these two? Right there. We add them. We don't subtract them. We add them. So on the top, we're going to get x to the 7. Okay? And this is where Jayla likes to keep a 1 here. How many of y'all like to keep a little 1 there? Usually it's about a third of the class, roughly. Okay? So what is it I do to these two exponents? Add them. And don't move them. They're not negative. They're positive. Leave them right where they are. Okay? Does everybody see? Okay. So I'm going to pause the recording, and I'm going to pause and let you guys work the next 3 problems on your own. All right, so I'm going to do them, and I've answered several questions on it, and they're all good questions, so I make sure everybody knows the answers to all of them. The key to making this easy is to move things so that you don't have to deal with negative exponents. That's the key to making this problem easier, okay? You have a lot of rules to remember. When do I add them? When do I subtract them? When do I multiply them? You also have to know your rules. And when do I not do either one? When do I just reduce? And that's with coefficients. So you reduce that coefficient. Negative 2 divided by negative 4 is positive 1/2. What do I do to these two? Subtract, and they end up on the top. What happens to these two? Y squared over y squared will be canceled out, gone. No y's in the answer. Are we good on that one? And I got a couple of questions about the next one, okay? So first of all, remember you don't move anything unless it has a negative exponent on it. You do not move negative coefficients. You leave them where they are. And what's happened here is we've ended up with these two y's this way, not this way, okay? So what do I do to those two exponents when I get to them? I add them. And what do I do to these two exponents? And leave them where they are. They aren't negative exponents, don't move them, okay? We end up with 7 x's down on the bottom. X to the 7 on the bottom and y squared on the top. Did I do the y backwards? You did it? Oh my goodness. Okay, sorry, let me fix it. You're not gonna catch me when I mess up. So, we ended up with like everything on the bottom, right? Yeah. All right, so there we go. The only thing on the top is the negative 1, and we end up with 2x to the 7 and a y squared on the bottom. Okay? What was the goofy thing in this last example that was a little bit wonky? Y to the 0. Very first thing we did, just to see if you could go back and remember what I said about it. Okay, so what's right here? 8 divided by negative 2 is? 4/1. It's negative 4/1, yes? Everybody gets a negative on there? Move that negative up to the top. What do I do to these two exponents? Add them. X to the, what's that, 3? So it's x to the 8. And several people asked me about this. What is y to the 0? It's a plain old 1, so I can just get rid of it, because times 1 isn't going to change anything, and leave my y squared at the bottom. If you wanted to leave that 1 with the y squared, I'm not going to get upset with that. You also do the job. Okay? Now, if you look through the homework, it starts off easy, sort of like just move things. Okay? Take a look at the second page of the homework. You may use the calculator. It isn't going to help you that much, but if you want to double check your arithmetic, you get more complicated problems there, and on the third page also more complicated. So in addition to this, you have a review sheet that I'm going to collect. The review sheet material is not on your next quiz, but it's going to be on the test at the end. I just want to make sure that you haven't forgotten. Sort of like the stuff from the first part, okay? All right, you want to tell everybody bye? Bye. Hope y'all are feeling better or not too cold in DC.
So thankfully,
And
she